Hey, third grade, happy Monday. Miss Fifield here to walk you through your week 7, day 1 of your new packet. So if you have that, go ahead and grab it, grab a pencil. If not, just grab a piece of paper and we'll get started. Your daily warm-up says, look at the tally chart below. Each tally mark represents one student. So along on this side, you see the favorite, these are showing us favorite pets. We see pets, cats, turtles, fish, dogs, lizards, and then the number of pets. So each of these little lines or tally marks represents one pet. How many students chose turtles as their favorite pet? So we find turtles, and then we look over here and we count 1, 2, 3, 4. So 4 students. How many fewer students chose lizards as their favorite pet than chose cats as their favorite pet? So we're going to look at lizards here and cats. All right, we have how many for cats? 6 for cats, and we have 2 for lizards. Okay, there's a really important word in here. Hopefully you already saw it and thought about the word fewer and what that means. Another word for fewer is less. So how many less students chose lizards than cats? When we hear that word, we know that we need to subtract 6 minus 2. So there are 4 less students who like lizards than who like cats as their favorite pet. All right, down below, we use the tally chart from above to complete the picture below. The first one has been done for you. So this down here is showing that each of these equals this one. There we go. Each of these equals 2 students. So 2, 4, 6 like cats, and that we can refer to the top to make sure that's correct. I'm gonna draw little squares with this tool here. So for turtles, we have 4. So if each box represents 2, 2, 4, I need 2 boxes. Oop, I have a circle. Let me fix that. All right, 1, 2 boxes represents 2, 4. All right, fish is next. So we look up to the top. How many students like fish best? 2 students, so that means 1 box. Okay. And then we have dogs. You see, I know that this group is equal to 5 without counting, because after the 4th line, the 5th one goes this way. So if you see a group with a line this way, you can just automatically know that that equals 5. So we have 5, 6, 7, 8. So we can count to 8 by 2. So our box is 2, 4, 6, 8. And lizards, 2 kids liked lizards, so that means just the 1 box there for lizards. Okay, our warm-up is all done. Let's take a look at our new learning. So I see a number line here. Let's see what this says. Locate and label the following fractions on the number line. Over here we see this says, I notice that all of these fractions are thirds. That means I need to partition my number line into thirds. So all of these denominators are all thirds, so that's their units here is thirds. Okay, so between each whole number, between 3 and 4, there's 1, 2, 3 parts for each, so that the whole number line is partitioned into thirds. Down below, this box here says the number line begins with 3 because all of the given fractions are greater than 3. So that means all of these fractions, the smallest one was this one, 10 thirds, and that was greater than 3 wholes. So they started this first endpoint as 3. Now we see the fractions I have to find and label are out of order. To help me place them on the number line, I can first label the whole numbers as thirds. I'll box them so it's easy to remember. They represent whole numbers. I can count by threes to find each number of thirds. 1 whole equals 3/3. 2 wholes equals 6/3. 3 wholes equals 9/3. 4 wholes equals 12/3. 5 wholes equals 15/3. 6 wholes equals 18/3. And 7 wholes equals 21/3. Now it is easier to label all of the given fractions on the number line. So those are these boxes here, these whole numbers, okay? Let's try one together. Locate and label the following fractions on the number line. What's the denominator for each fraction? How can you partition your number line using that information? So let's look at our denominators. All of our fractions are sixths. To partition each whole, so 1 whole, 2 wholes, 3 wholes, into 6 parts, we need to draw how many lines? 5 lines. So you can use your marker or pencil, whatever you're working with. I'm going to use a marker and draw 5 lines that are as equally spaced out as possible. Okay. And then once you've done that, we want to label our whole numbers. So we know 0 wholes would be equivalent to 0/6, and that's actually one of the numbers we need to plot anyway. And remember, we box these. Okay, 1 whole would be equivalent to 6/6. There's another one of our numbers here. We've got 2 done already. If 1 whole is 6/6, 2 wholes would be how many sixths? 12/6. That's another number from up here. All right. And 3 wholes would be how many sixths? 18/6. Okay. So we've already got 3 of these. I'm going to cross these off so I know that I'm done with these. We have 3/6 and 9/6 to find. I'm going to start at 0, 1, 2, 3. Label 3/6. Need 9/6. So if I start at 6/6, 7, 8, 9. 9/6. Okay. That wasn't too hard. I'll leave that up for just a second. You can always pause the video too if you need to. I just want everyone to be noticing how we're drawing these and that all of the pieces that we've partitioned are all the same size or as close as we can possibly get it. So I want you to pause and look at mine and then look at yours and make sure that yours is as equally spaced out as mine looks. And if not, make sure on the next one you really focus on that, okay? All right, so we have a new learning example number 2 in your packet. This says, students measure the length of their earthworms in science class. Nathan's measures 3 inches long. Alicia's is, oh, that's so small, 15/4 long. Whose earthworm is longer? Draw a number line to prove your answer. So they started with the number line, and they started with 1 whole inch, 2, 3, and 4, and then put the equivalent fraction in fourths because the fourths came from right here in the example they gave you. So 1 whole would be 4/4, 2 wholes, 8/4, 3 wholes, 12 fourths, and 4 wholes, 16 fourths. Across the bottom here in these different boxes, the first one says, I know Alicia's earthworm is measured in fourths, so I need to partition my number line into fourths. I know that both measurements are greater than 1 inch. I can use that information to choose where to start my number line. That is why they started here with 1 whole inch instead of starting at 0. I can label the whole numbers with their equivalent fractions by counting by 4s. So 4, 8, 12, 16. Skip counting by 4s because your denominator is fourths. All right. Then we see over here, we see the same number line, but they show us it again. And then there they've labeled Nathan's earthworm because his is 3 whole inches. And then Alicia's was 15 fourths. So he used 12 fourths and then counted on 13, 14, 15 fourths. Now I can plot and label Nathan's and Alicia's measurements on the number line to compare whose earthworm is longer. Alicia's earthworm is longer because we can see that this 15 fourths is greater than 12 fourths, which is equivalent to 3 whole inches. Okay, let's try. So we have another example in this and we're going to work on together. Allie wants to buy a piano. The piano measures 19 fourths feet long. She has a space 5 feet long for the piano in her house. Does she have enough room? Draw and label a number line to show and explain your answer. So she's got 5 feet of space, and then the piano that she wants to buy is 19 fourths feet long. We need to figure out if that is greater or less than 5 feet. So they've already given us the number line. We don't have to draw our number line, and we also don't have to label our endpoints. Those have been done for us. So I see 4 feet here and 5 feet here. It's also already been partitioned into fourths. 1, 2, 3, 4. How many fourths are equal to 4 wholes? We need to skip count by 4 times because 1 whole would be 4 fourths, 2 wholes, 8 fourths, 3 wholes, 12 fourths, 4 wholes would be 16 fourths. So we will label that endpoint like this, 16 fourths. Now you can either skip count by 4 again, or you can count here, 16 fourths, 17 fourths, 18 fourths, 19 fourths, 20 fourths, just like this. All right, and how long was her piano that she wanted to buy? 19 fourths, 16, 17, 18, 19, 1 less than 20 fourths. Oops. And is that less than or greater than 5 feet? It's less because it's on this side, which is closer to the 0, so it's a smaller amount. So does she have room? Yes, she does, and you can write a statement below. I'm not going to do that because you know how bad I'm at writing with the marker, but you could write something like, yes, she has enough room because 19 fourths is less than 20 fourths, which is equivalent to 5 feet. Okay. Now here's your problem set. These are the last 3 problems that you need to do. You can pause the video and complete these on your own and then come back, press play, and watch me do them. If you feel like you can do these independently, otherwise you can do them with me right now, okay? Number 1, locate and label the following fractions on a number line. The number line is given to us. We have 1, 2, 3, and 4. Our whole numbers are labeled there. Our denominator or unit for all of these is 4 fourths. So that means, is fourths. So we need to label and partition our number line into fourths. 3 lines makes 4 fourths. Remember, we're really focusing on trying to make these equal parts, each piece. Okay, now we start with our smallest endpoint, which is 1 whole. I know 1 whole is equivalent to 4/4. And I noticed that that's a number, one of the fractions here that they gave us. So I can cross that off because that one's done for us. So we have 4/4. And then we can skip count by 4s to label all the other whole numbers. So if I have 4/4 here, this would be 8/4. And I am boxing these because these are equivalent to whole numbers. I have 4, 8, 12, 'That was another one. 4, 8, 12, 16. And that was another one. So right now we only have one more fraction to find here, and that is 6/4. Here's 4/4, 5/4, 6/4. And I'm not going to box that one because it's not equivalent to a whole. I only box these because they are the same as a whole number. All right. Number 2, locate and label the following fractions on the number line. So we're doing the same thing. This one has 2, 3, 4, 5, and 6. And our unit is thirds. So we're going to decompose or partition each whole into thirds. 3 parts means 2 lines. So go ahead and partition your thirds. Okay, we're going to start with 2 wholes right here because that is our smallest endpoint. So we know 3/3 would be equivalent to 1 whole. Therefore, 6/3 be equivalent to 2 wholes. So go ahead and label and box that. 6/3. Mine's a little sloppy. And then we can skip count by thirds across to label all the rest of our whole number equivalents. So if this is 6/3, this will be 9/3. And of course we box. I notice that it's up here, so I can cross that off. 6, 9, next would be 12/3. That one's not up there, so nothing for me to cross off. 6, 9, 12. Next is 15/3. I don't have lots of room here, so I'm just kind of putting it here. 15/3, and I box. That was also not one here, so I don't need to label that either. And the last one would be 6, 9, 12, 15, 18. Thirds. And I boxed that as well. All right, and that was our list at the top. So we have 2 more we have to find. We have 14/3 and 11/3. So let's start with 14/3. You know that's going to be right before 15/3. So 1 line before. I'm going to label that, but again, I'm not going to box it because I'm only boxing right now things that are equivalent to a whole number. So there's 14/3, cross that off, and the last one's 11/3. I know 11 comes right before 12, so 12, one more before, 11/3. Okay, last one. We have a word problem at the bottom. And this is, let's see, there we go. For a measurement project in math class, students measure the length of their pinky fingers. Alex's measure is 2 inches long. Jeremiah's pinky finger was 7/4 inches long. Whose finger is longer? Draw a number line to help you prove your answer. Okay, so the first thing we need to do is we need to start with a number line, right? So let me give myself some more room here, and I'm going to get a number line. Okay. Seems like we could do one whole 1 inch as this end point and 2 inches as this end point. And our denominator, our units here is fourths. So in order to decompose this whole into fourths, I need 3 lines. So I'm gonna go right in the middle and then on either side, like this. Okay, if these are fourths, 1 whole is equivalent to 4/4. 5, 6, 7, 8/4. These are other number. All right, now our number line is set up. Now we just need to put these lengths on our number line. So Alex's measures 2 inches long. 2 inches is equivalent to 8/4 right here. Just put a little A so I can remember that I'm talking about 2 holes there. And Jeremiah's was 7/4 long. So we have to find 7/4. 4/4, 5/4, 6/4, 7/4. So here's his. I'll put a little J over here so I remember that's Jeremiah's. Whose pinky finger is longer? Alex's or Jeremiah's? Alex's, because it is further away from 0. You can write a statement to answer that. Alex's finger is longer than Jeremiah's finger because 8/4 is greater than 7/4. And that's it for today. Great job. Keep working hard. If you need help, just keep reaching out to your teachers. We're here for you, and we will talk to you soon. All right. Bye.